Back today we're doing problem 283, move zeros. Given an integer array nums, move all the zeros to the end of it while maintaining the relative order of the non-zero elements. Do this in place without making a copy of the array. Let's look at the examples. So, given nums here, we see that these two zeros at the front are moved to the back. We also maintain the relative order of the other elements. So you have 1, 3, and 12. Second example, when you're given just a 0, you output just 0, right? So here, note that you must do this in place without making a copy of the array. So if we were going to make a copy, what we could do is, this would be it's a pretty straightforward problem, but let's just try to think of this without the constraint, right? Like, how would you do this problem if there was no constraints that were provided? So one way you could do it is you could just copy all the numbers that are not zeros to the new array, right? Make a new list, add all the non-zero numbers to the front of the list, and then you can append the number of zeros that you see from the original into the back of that list. Straightforward, easy. Okay, now let's do it without using a copy of the array, right? So if we have some list like this, just gonna put examples in here. The way that we're gonna do this, right, is we'll count the number of zeros in the list. After we've counted the number of zeros, what we're gonna do is place all non-zero numbers into the front of the list. We'll use a pointer to indicate which position that we're at, and we'll move all the non-zero numbers to the front of the list. So at that point, what your list is going to look like, it's going to be a 1, this is going to be a 3, this is going to be a 12. Your list is going to look like this, technically. Now, loop backwards and replace, let's say that this is equal to k, right? The number of zeros in your original list is equal to k. You're going to loop backwards and k times and replace nums at that index. Let's say I is going backwards equals to 0. So you're just going to replace them with zeros. So at the very end, what you'll get is, if we were to step through this, you would k equals 2 in this case, right? There's 2 zeros. So you'd replace 12 with the 0, 3 with the 0. That way, your list comes out to this, the correct answer. And you do this in place. You don't use any extra memory. You use two variables, one pointer for where you're going to be placing the numbers that are non-zeros at, and then another variable to maintain the number of zeros. So let's get started. 0 is equals 0 for number in nums. We're going to loop through. If number is equivalent to a 0, we're going to increment the number of zeros that we see, right? Now, following this plan that we have here, right, what we're going to do is place all the non-zero numbers to the front of the list. Okay, well, let's say front index is equal to 0, right? This is the position at which we're going to be placing non-zero elements, and this will increase as we see non-zero elements, right? So first we'll start here. This is the first front index, first non-zero element, where it should go. Then it'll go to 1, 2, so on and so forth. So we're looping again. Okay, we're going to loop through nums. If the number that we're currently at is not a 0, what are we going to do? We're going to replace the number with the front index to be nums at I, and then after that, we're also going to increment front index by 1, right? So this is step 2. Now, step 3. At this point, our list is going to look something like this. Now we have to loop back this many times, k times. K is equal to the number of zeros. We're using this variable zeros here. And then we're going to replace the number at the end with a 0, right? So while zeros is greater than 0, what we're going to do is say j is equal to the length of our nums minus 1. Nums at j is going to be set to a 0. J is going to decrement. Zeros is also going to decrement, right? I'm going to zoom out a little bit here. Move this over. So this is step 3. And at this point, I think that's pretty much it. Why is this not feeding out? Okay. Let's run this and see if it works. Hopefully I didn't miss anything. Great. Nice. So for this problem, right, they said not to make a copy of the array, do it in O of n time. This is actually running in O of 3 times n, right? One loop to count the zeros, one loop to put the non-zero elements at the front of the list, and then another loop to put the zeros at the very end of the list.